Hello, hello. I continue working on the minicast. And hopefully we can do a hello world. At least in a little bit. So right now we are compiling, no, not compiling, right? Like, but processing this thing in order to do print hello world. Hello, Nigel. Fastest programmer on the planet. That you? Hello world. So we want to define the function print right now. If I try to do this, well, it's going to say that print hello world is not an expression. Are we finishing minicast today? I don't know about finishing, but like getting it to a usable state, maybe. I think it will maybe require a couple more streams though to make it like. We'll see. We'll see. I don't know. Like there is no code generation yet, right? Like I'm just parsing and I'm barely parsing anything, right? I don't even parse a function application right now. So let's do that immediately. Parse the function application, right? We just do this. If rule name is equal to apply, then test mini syntax. Let's take a look. We have a thing that's called apply, so it's just function and args over here in parentheses in a second anonymous group. Okay, let's say that function is root children tuple get named f is the unwrap child value. And then args is root children get unnamed at index 0. There is only one. Unwrap child group. So this is going to be a group, and then we say args. This is a group. We're going to say AST helpers expect single child with name args. Good morning, gatherer. This is going to be my arguments, and then we also say that args is expect rule called no, we don't have scope. Yeah. Args AST is this. Let's go to AST, unwrap child value. we're going to have unwrap child group, which is going to be group, then return group. Otherwise, if it's a value, then we're going to panic. Expected group is chili child, get value. Right, so this returns AST, and this returns the AST group. Okay, so we have the arguments. Args is new array list for arg in AST iterate list of the args AST. They should be separated with a comma. Right? So we say binary rule name is comma, trailing or leading rule name is trailing comma. Okay. And so over here, we say arg. So every argument is an expression, right? Parse expression arg. We need to calculate the expected type argument type, expected argument type. And this is going to be my argument, and then we say args push back arg. Then we return. Shape is apply. Function with arguments. Type is. So we need to first calculate actually. Here's my function, right? I need to first figure out what is the function that I'm trying to call, right? F is parse expression. Parse expression F, right? So what is the expected type of function? We don't know actually, right? So probably we don't expect anything here. Now we have the expression, right? So function type is, we're going to match function type, and this one has to be a function, right? So it must be a function. If it's not a function, then this is an error, right? So we need to do the diagnostic. But type, when we apply the function, is going to be the result of the function application, which is function type result, right? Over here, we're going to say expected function got, and over here, what do we got? We got print type name of the function type, right? Like this. The span here is going to be, let's call this FAST. It's going to be FAST span. Now we need to calculate the expected argument type, right? Which means that we will do the argument index or something here. It will do argument index plus equal 1. Actually, maybe like before parsing the inner expressions, we should like calculate the things instead of type checking them immediately. Yeah, how about this? Yeah, sure. Let's say arg ASTs, args is arg ASTs. It's different from args AST, right? Over here, just say. So yeah, later I will just say for index argast and argast's array list into enumerate this is the actual args. We don't need the array arg index because we have the I here. But over here we are going to collect the arg ASTs first, and the reason for that is because I want to know the length of this. Right? So we're going to say that if arg ASTs length is not equal to function, okay, let's say actual arg count is argast's array list length, expected arg count is function type args length, right? So we say if actual arg count is not expected arg count, then we're going to do another diagnostic over here, another error, right? We're going to say expected arg count args got actual arg count, right? And this is going to be in like the args AST span. Okay. All right, so now we know that the amount of arguments is the same. Now we have the index, and we can say that the expected argument type is just equal to some function type args at the index, like that. I think that's all, right? So we are doing everything that's needed here. All right, I also know that we can have a token which is a string, in which case we need to return shape is, so like what is, first of all, the type is going to be string, right? But what's the shape? If this is a token like that. Wait, or did I want to make the strings only be present in the constants? Is that what I wanted to do? I mean, this is okay. Shape is... So this is going to be string literal. Right? And we only care about the contents here. So expression can be a string literal string. I think I'm going to at least like parse the hello world. The only issue is that the hello world, the print here is it's supposed to say that print is not found in the current scope. At the same time, if we define something like print is as string and if string and this returns nothing, right? And we just say let's just say foo s, right? This is supposed to work because s is supposed to be in the current scope. We are doing that. Match branch must use fat arrow. Optional string is not string. Over here it says some. Forgot a comma. Alright, it says foo is not found in current scope. Right? Foo is not found in current scope. If I comment this out, it's going to say expected string got string. Because strings are different. Right? This string is a new opaque type which we call string. That's not like the native string type. So we probably should say something. Hello, Hisoka. Good morning. Good morning. Gatherer. Good morning, Hisoka. Good morning, everyone. So this string, yeah, I need to like make sure that this is a known type, right? Yeah. So something that's actually known to the language. Fine. I guess we will do a native string then here. And similarly, native int32 and native, because I think we will have to know what a boolean is anyway. right? Yeah, because like for ifs, for sure, we will need to. Not sure about the integers, but maybe we will have to do that too. So this means that when I define a type define, right, we have the opaque type, but I also say that if rule name is equal to native, right? Type native. Definition is the definition. I think we can do a type def here. Native. This takes the definition, which expects to be a record. In this case, we don't. I say that definition is children get, let's just say root, expect single child with no name here. Yeah, so basically if the type is a native type, then I need to process native type name def, right? Process native type name definition. So the definition must be the thing. It's going to be yeah, and then the type is like depending on that stuff. Okay, so definition is let's do it return here. If definition is if definition shape is token, if token shape is string, right? Then return. In other cases, we'll do the diagnostic. Native type expected as string literal as a name of native type, right? And this is supposed to be in the definition span. So over here we are going to say that name is as content, right? So now we will say that if name is equal let type be we do over here. Let type be this, and we add to the name the type. Sorry, here we say that if name is equal to int32, then we're going to return the int32 boolean string unit, right? In other cases, we are going to we're going to say string escape name is not valid native type. Like this. So the types, I do not have the, but I need to have the int and a boolean after all, right? I think the next step would be... Wait, no, this is type definition. Hold on, type definition. Type definition. Yeah, because like, yeah, we're going to have just an alias to the native type in that case, right? Yeah. Like, we're going to generate code which actually uses int32 instead of like the native int or whatever. And we're just going to create an alias to that. So this is the type, and there's going to be the alias to type. And if we have aliases, it means that it's actually going to not work properly. I think. It's not going to type check. Because when we are considering aliases, I guess, we should consider the types to be equal, right? But I'm not considering alias to be the same. I mean, this is the wrong native, though, technically. It's okay. Right, it still says expected type string, but got string over here, right? Because one of them is string, which is an alias to the native string, and one of them is a native string. So what we can do is when we parse type, I guess, if it is a token identifier, right, we're trying to get the name of the type. Oh, but over here we don't know. We don't know here. We only know the names of the types, not the definitions. So how do I compare them? Would be a question. So maybe I fix the type check then, right? If we have expected type and actual type, I need to first resolve aliases when I'm doing the type checking. Can I make the language simpler? Like, how do I do it without the aliases? Like, I need to get rid of the aliases, basically. Right? It's just because I am inferring the type to be a specific thing. Yeah. No, I think I need to. I don't know. I have to do aliases, maybe. Resolve type aliases. Resolve type aliases. Resolve type aliases is a function that takes type and returns a type, right? Which now matches type with the things, all of the types that we can have, right? So it's a unit, then it's unit. If it's int32, then it's int32. If it's boolean, it is boolean. If it's a string, it's a string. If it's named string, it's named name. This is where we do something. If it's a function, args and result, right? Then we need to return function, args and result. But we need to first say that result is a result type alias is a result, and we need to say that that's I just need to do this. Recursively resolve the args. And we have it named, right? So then we say that definition is... So this is like the only thing, right? If the definition is... current context... type... program... types... or map get name, like it's supposed to be there, right? We already know that it exists technically. So this is the definition, and then we will match the definition. And if the definition is alias, to type, then this is going to be resolved type aliases type. And in any other case, we can return the original type, which is just named name. So we stop the recursion when we see a named new type. Yes. Expected string got string. Still. Hold on. So print the function text string. But over here, this is a string. But it's a different string. Still. Why? I should like make the natives something. Like, can I make the native colors? Do I color them? Or do I do something else? I can also say like this maybe. Like this is native with triangular brackets, for example. And then we will be able to see the distinction. I mean, yeah. Expected type this, got that. So it means that we were resolving the type aliases. And then they were not equal still. Which is weird. Oh wait, they're not they will not be structurally equal if they are lists. Yeah, I think I'm not checking lists for being structurally equal actually. And that's the reason. Right? Like if I say cast bootstrap, right? And if I say something like A is array list new, push back A. So A and B are both like the lists like this. They're supposed to be equal to each other. std wrapper structurally equal A, B is supposed to be true, right? But we want this to be Let's have a function that returns the list. Push back A. Let A be F. Let B be F. dbg print std wrapper structurally equal AB. So this is what I want. Kast bootstrap. Let's run this. So this is true, but if I run this, target is JavaScript. No, it is still true. Okay. So that's not the case, probably. So this is the error. We expect a string, but we got a native string, right? Because this is an alias. But since it is an alias, well, I was supposed to resolve the type aliases. Expected actual. Right? Because we have a named type. And the name type is an alias. Right? Okay, let's do this. Guys, it got so big we are making a mini version now? Yeah, exactly. Exactly. I'm just trying to self-host. Self-hosting the full version is going to take a long time, but making a mini version will be pretty fast to do, which is good because I can improve my compilation, my like compiled output, and I can change my compiler target by changing the bootstrap to compile into the mini version, and then doing the rest of the work in the self-hosted code. For now, there is only one issue. It is the compile times. We are already at 31 seconds of compiling this stuff, but we do have almost 11,000 lines of code already here, plus 2,000 lines in the standard library, so like 13,000 lines of code is what I'm compiling here. Right? Oh wait, string is an alias to int32. Okay, hold on. This makes sense. This makes sense. String is an alias to int32. That's not correct. It's probably because in my test, I wait, what native string? Okay, no, it's not here. The problem is string. Right, this over here is a problem. Boolean string unit Boolean like this. There we go. Okay. Incremental compilation wanted. Yeah. It is definitely wanted. I'm actually wondering though. I think that like saving the compiled stuff to the disk is probably not what I want to do, because like there are a lot of issues with that. Unless I like, I mean, I want to do like the least amount of work possible. But what we can do is we can like make a compiler which like just stores the compile state in memory, which we already have technically. We have a thing called compiler cache, and then like instead of like calling a script just build, we just like tell the compiler like recompile the thing while compiler is going to be running constantly and like waiting for the input to recompile basically. And then when we recompile, we see the files that are changing, we invalidate the cache, and then we recompile. This actually might be worth it, because yeah, there is still potentially some miscompilations that are going to happen because of that, but I think maybe this is already going to be better than nothing. And that is relatively easy to do, actually. Maybe I should do that before we continue working on the minicast, actually. Yeah, I think your Go project compiles for 1 minute on CI, full compilation, or 2-3 seconds after a random change in the source code. Yeah, I don't do any incremental compilation at all. It does make sense. And in terms of like incremental compilation, we have compilation units currently, kind of, which are the files. I don't think that I'm going to do the like the smaller compilation unit, so like for like even better incremental compilation. We just need to not recompile the same like stuff multiple times, right? Because I'm every time trying to compile the standard library and all of these files, everything from scratch, right? Even although I'm working on the minicast, I should like basically the dependencies of the minicast are not changing here, so why are we recompiling those? So yeah, we could do that. Which is same as how my like language server was working at some point. But there were issues with that too, by the way. I don't know. I mean, we can try. It's just I expect some miscompilations if we do the incremental stuff, and I don't want to debug it. That's why have not done it yet. All right, I have successfully done that. Is alias do this? Okay. Log trace. More mini expressions. All right, do I open and make the incremental compilation? Here, like I literally want to recompile only when I say do recompile, you know? Explicitly. Maybe then it's not going to be that bad. And then we sometimes will still do it from scratch then. So here's my compiler CLI, I guess. It would also be cool to not recompile and non-significant changes around like formatting. Yeah, but that like is not that easy. Especially in the presence of like, I mean, so technically we are allowed to have macros, right? And the macros can look at the source code, including the positioning of the source code. So like making that work, like we don't do that right now, but in the future, you know, we would need to figure out if the macro depends on the on the positioning of code and everything, you know. But yeah. I mean, ideally, there is like a lot of granularity that you can do. Line information for debug would be screwed though. Yeah. Like, I mean, maybe you can like have the abstract line information, and then when you do the insignificant change like this, when you format, you can like, instead of recompiling everything from scratch, you just like migrate the line informations, you know, from like the old to the new places. Something like that, you know. So Kast compiler CLI over here, I want to basically have another argument type, which would be what, like it's not like the watch, it's like, I don't know, let's say continuous compilation. Is that what I want? Continuous compilation? Recompile. Recompile. I don't know what's the good name for it. Continuous, like basically we'll have the command line compiler to, after compilation, to wait for the user input and then continue and recompile. Fine, I will call it continuous for now. Continuous is false by default. Continuous is true. So over here, see, I'm initializing the compiler cache, basically. So this is just an in-memory. We're not going to put this on the disk. We are instead going to say that this is my cache, which I'm going to do once. Right? And then we're going to do a while true, basically. We are going to do all of that. So this is the entire compilation stuff. But in the end, after I finish the compiling, right, I'm going to say that if continuous, well, we can also say like while continuous, basically, right? Or something. While true. We basically say that if continuous, then this, otherwise we can break. Wait, can I not break out of the loops? Do continue is true. While do continue, do this. So else we say do continue is false, right? But if it is continuous, then we will like read line flash standard output, then read characters from std in until a new character is encountered, right? Read line string trim input is this, and then we say that do continue is input is equal to yes. I think like explicitly yes, or what, R. Actually, I don't care. We're just going to do Control C to stop. So I'm just going to say ignore the result of read line then, right? I'm just going to first also print string, you know, press enter to recompile, right? Then we read line. And now I need to clear the caches though, like that's the important part, right? That is the important part. So how do I figure out what files have changed, right? I do have in my caches. So in my cache, I have this. Basically, compiled, imported, yeah, dependence. So I can invalidate a particular URI, right? I think I'm just going to go over all of the files that I have parsed, I guess. And I just need to figure out if this file has changed since I started the compilation, right? I think there should be a way to do that in OCaml, right? Cache parsed URI map iterate function URI. I don't care about the parsed itself. I just on the URIs, right? Yeah. If file was changed URI, then we say cache compiler cache invalidate URI, right? So this is only thing that we need. Like, what does it mean that file was changed? So maybe when we start the compilation over here, file was changed. I can just say true for now. Let's see here. I'm just going to say cast compile continuous examples hello, right? Like this. So it says bad file descriptor. Wait, what? It says bad file descriptor. When I output string, I cannot write anything to the std out. No, why can I not write anything to std out? Am I closing std out here or something? We say close out out. Oh, I do say close out. Yeah, I close the std out. Can I, like, not close the std out? Well, I mean, I guess we can say that output, right? We can say compile continuous output target compiled txt. This is the like, yeah, there we go. So we have in target compiled txt, right? This is the intermediate representation basically that we have, and then I can like recompile here, and it will say no recursive imports. Okay, it's already broken. No, I think I cannot do the incremental compilation at all unless I fix the no recursive imports. But why does it think that it's a recursive import? It's because the thing is in progress. I've been compiled, right? I've been imported. At fake prelude, I'm trying to import the standard library basically, and it says the no recursive. Which is very weird. Oh wait, or is it because... Hold on, I'm actually wondering what's happening here. What am I actually importing? No, yeah, like, see, this is the full path to the standard library, right? That's the only thing that we import here. And over here, I'm importing the same thing again. I have not cleared my cache. So over here, I'm adding that it's in progress. And over here, I have imported it successfully. Let's log in for here too. This is a weird bug, right? I have imported it successfully. Then I recompile. I'm trying to import the same stuff. And it says no recursive imports, right? Like, that makes no sense. It's probably because the cache is empty or something. No, this makes zero sense. Right? Because I'm adding to the URI that it actually is imported now. The URI did not change here. No, it didn't. Like, it should instead say imported from cache. Log error. Let me just like do cache imported iterate function URI state let state be match state with imported in progress and then I like and then I do the log error here. Let's do this so that I know what are the current states of everything. Right? Yeah, it says that standard library is in progress. Why? Like I definitely got here, right? Okay, let's do over here. Let's do it twice, right? Before this line and after this line, right? I'm supposed to do the add. Oh, wait, hold on. Does the add in maps in OCaml not update the key? There's no way. Is that how OCaml works? Oh, hold on. Let me look up the documentation. OCaml map. This is infuriating if it is so. Like, it doesn't say. Okay, this is the documentation, right? Map make as. Right, let's see. If key was already bound to a value, which that is physically equal to data, M is returned unchanged. Otherwise, the previous binding of key in M disappears. Before 4.3, physical equality was not ensured. No. This means that it does overwrite, for sure, right? Yeah. Because they are not physically equal. Let's run this again and see. Right, see, the standard library is imported. Then I'm recompiling, and it now says that it is in progress. Do, 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 do. Yep, imported. Yep. Let's do it in the compiler CLI. Here's my cache, like before I try to do anything. Let's do that. Do I re-export this? It's compiler cache. No. Module. State. It is in progress. There's no way. Do I have undefined behavior or something? So over here it is imported, right? I am importing. Yeah, like I'm only saying that it's in progress when I'm importing. And this never happened again, which means that I'm still having the old state. No, it's not undefined behavior. It's because the maps are pure in OCaml, right? We're like adding to a map. Like I, for some reason, stick to the old thing probably. Somehow. Which would be weird though. Imported. In progress after I recompile. That's why I didn't want to like touch the bootstrap, because like there's weird bugs everywhere. I'm going to fix it and like introduce another bug or something. I like how I'm looking like I hate OCaml. I'm looking for references to this field called cache and it's showing me this. What the hell is that? That's not a cache. Can you do this again? Can you do it better? Okay, now. Okay, there we go. We dislike in OCaml today. Every time we go into OCaml, like code base, yes. Every time. First time. Well, I mean, maybe it's like my issue in this case, but I will blame OCaml anyway. Because we like blaming OCaml for everything. I mean, I'm wondering what the bug is here, but like, how do I figure it out? I just need to print the state of the cache more often, right? Let's make this function called cache compiler cache print. Yeah, how about this? Log state. Cache state. No, I'm not doing multi-threading currently. At all. It's all single-threaded. Multi-threading would be another thing to fight. For sure. So the cache state is empty, and then we recompile. Wait a second, what? Why is the cache state empty again? Hold on a second. Something is really wrong. We're multicasting here. There's no way. It says that the state is empty now. Wait, so like I literally just extracted the thing into a function, brought it into the library, and I have different output? Oh, maybe it's not different output. Like this is just printed when I'm doing the error. Okay, all done. All done. No recursive imports. Like this over here is going to be just cache log state of the cache. The cache state is empty. Okay, that's why. Actually, this does explain it. It actually does explain it here. No. It's because, like, I'm actually supposed to only import the standard library once. Because once I do that, like, there's the prelude. Or this is the thing, right? Which is adding the import to the standard library. Basically, for everything that we compile, right? But we do not need to import the standard library from within the standard library, which means that once I have imported the standard library, like, basically, like, I guess it's done with the global state currently, where have I imported from the standard library yet or not is a thing. You know? So because I have already done that, I'm basically injecting the prelude into the standard library, which tries to import the standard library from within the standard library. The question is, though, why is my cache empty? Because I did not clear it, right? Or did I? Right, because I'm creating the cache on the outside. Here. Oh, wait, it's because file was changed is true. Yes. File was changed is true, which means that I have cleared the entire cache. If I say false here, it's going to work. It's not going to work. Compiler cache log state cache. Like before I press enter to recompile. How about this? It's empty. Why is it empty? It's not empty. You're lying to me. Hold on. Now. Am I using a different cache? There's no way. Oh, wait. It's not used. No. Hold on. Cache? No. No, it's... No. That is wrong. When I'm logging the state, it's logging the importing state. Okay. I guess technically that's what I want imported, right? Not parsed. How is it empty? I don't get it. It's like I'm using a different cache. Oh, because it's okay, hold on. If it's no STD, then I'm using the cache. And if it's not no STD, then I'm still creating the new cache. Okay, default. Cache over here is optional. There we go. We need to say cache here too. That explains it. Okay, nice. Recompile. Okay. Yeah, it's my bad. It's just like this function has an optional argument, so I didn't see that I'm parsing it actually here, which, yeah. Optional arguments. So, so now we need to figure out if file was changed, right? How do we do that? So I think in OCaml, file, maybe it's in the Unix. What do we need? Like file information or something? The type of file access rights. fsync. Seeking truncating file status. Return the information for the named file. Stats. What's stats? Device number, inode number, last modification time, right? That's what we want. Why is it a float? What? I thought it's an integer. So I think what we need to do is whenever we read a file, right, specifically source read, this already does effect perform read URI, right, which means that we can handle this effect. So I can detect that I'm reading a file, right, everywhere here. Let's do over here, do compile, and this is going to be do compile. So that's my recompilation logic then, right? We're going to try do compile, and if we have effect source read, so if I'm trying to read a URI, right? I'm going to forward this effect. And like do that, right? Read URI. Continue K. Like this. Right? So we just use this to detect that we're trying to read a URI. So when I'm trying to read, I need to record it its last changed a thing, right? Before, since the last compilation, basically, right? So let file modification times is going to be urimap new init urimap empty. That's going to be a ref, I guess, right? So file was changed. Yeah. So we need a file file modification time URI t. So this is going to be, right, like Unix stat the path, right? We just need to read from the file system as URI file path. Right, so path is the file path of the URI. We just need to check just that this must be a file, right? And then we stat the path, and then we get the M time, last modification time, right? That's what we want. So this is the modification times during compilation. Mod times at when compiled, you know? So file was changed is this, you know? We are going to say that we're going to match file mod times when compiled. Find the URI there, right? If it is not there, technically this is supposed to not happen, but let's say that it means that it has changed. But it's not supposed to be like that. If it is some time when compiled, in this case we're going to see the file mod time of the URI, right? So this is last modification time, right? And then basically I return last modification time is greater than time when compiled, right? This is not cast, I don't need the parentheses on the matches. Right? And then over here, when I'm trying to read, I only want to handle the effect while I'm doing the compilation, right? So over here, we are going to continue and we're going to actually read it. But before that, we're going to save the file modification times, right? So file modification time when compiled is file modification time when compiled. And we need to URI map add URI file modification time of the URI, right? Like this. Maybe I should log over here, you know, log info. Like this file was changed since last compilation. Right? And then we're also going to print recompiling like this, right? Right, so over here I'm trying to compile examples hello. So I press enter, I'm recompiling, but nothing was changed, so it doesn't really matter, right? If I say over here something like import, what do we have in examples? It doesn't really matter. Import lists, yes, right? I can do importing of anything. And it says no recursive imports. Again. Wait, the standard library was changed since last compilation? There is no way. I did not change the standard library, did I? Wait, I just saved the file and it says that stdlib was changed since last compilation and the example list was changed. Even although I did not change these files, I literally only changed hello. Hello? What? That's when I'm calculating the file modification time, right? This is going to be result log info mod time of this is equal to that result URI print URI. Right? So over here, we have some numbers, right? Now, I'm pressing enter. I did not save any file. Right? So I'm not even looking into these files anymore because the standard library is from the cache. So I'm only looking at the examples lists and I'm only looking at the stdlib because these are the only two things that are imported from the hello. I mean, and I'm also reading the hello. Right. And then wait, what? And then I pressed enter and it says that I'm recompiling because stdlib was changed just since the last compilation. There is no way. Who is changing this file? Hold on, stdlib is 17749. Hold on. Wait, it says was changed since last compilation after I pressed enter to recompile. No? Hold on a second. File was changed. This is after I'm pressing the enter. So file was changed. Oh, it's true because it's not in the URI map. Oh, wait, what? Oh, I see. Yes. Because, yeah, I for some reason made this map over here, but instead it should be like created at the same time as the cache, so outside of this loop. Right? Yeah. Yeah, the file did not change. If I save this here, it works now, right? So, okay, let's remove the logs again. Let's remove this log. So I'm only reporting the files that were changed since the last compilation now, right? Right, so this 1, 2, 3, 4 is because I'm importing the lists. List is the example, which basically is supposed to like run some code at runtime because I'm importing it, it's running at compile time instead. So I will see 0, 1, 2, 3 if I change the lists, basically, right? So let's change this file by saying 1, 2, 4, right? So I have changed this file, and it's recompiling, and now it's doing 1, 2, 4. Okay, maybe this is good enough, right? But if it breaks, like I still can see some miscompilations because of the way like things are. Unfortunately, I expect some bugs still. Continuous compilation. Right? So, but this maybe will help us with the incremental compile times. All right. Let's update Kast. Okay, what was I doing in the minicast now? Something. We need to do what? Start transpiling to JavaScript already, maybe? Even although we don't have everything needed yet. I don't think I will make the interpreter for the minicast. So the just file has a build. That's bootstrap args. Yeah, let's just say over here, continuous, right? Like that. So just build. Let's see if this works well enough. Right, so it's going to take, the first compilation is always taking like 30 seconds currently, but we just leave this open and then I will do like other things on the other terminal. I don't see the times now, right? But if I right now say recompile, enter, then it just transpiles immediately. Okay, it's still not... it still is relatively slow. I see, it's because like the generating of the JavaScript is actually relatively slow, right? It seems like generating JavaScript is also taking like 10 seconds. So we are only getting rid of the type checking. Might be called the watch too. I think watch is different because watch is compiling automatically without explicit input from the user, which is why I didn't call it watch. I don't want it to compile automatically when I change the files, I think. Because less potential for the compilation to break then. Okay, anyway, so like it does help, right? So yeah. It does help, it seems. Okay, cast conti is compilation. Yeah, I don't see the times anymore because this doesn't finish unless I make the time reporting inside of the cast now. That's okay. Actually, it's very easy to do so, right? Let's say do compile. Start is time. Try timed. Do compile. Compilation. Because timed is just going to log. Time for compilation is this. Yeah, there we go. Right. See? Compilation took 1 second here, but when recompile, it's 0.2 seconds. Okay. Sure. Report compilation times. Hello, Robin. Malfate. All right, now let's work on the thing. So, do I just start generating JavaScript, maybe? Because I want something to run, right? Minicast. Minicast. Let's see. So we will have multiple backends potentially. Right? And then we'll have the JavaScript here. So the JavaScript compilation is what? We need to have the input, which is the program, right? Which is a program. So I need to import this thing, and the program will return what? The string here, or like we can return the JavaScript AST, which we then could convert to a string. Because I think like when we compile to JavaScript, we also first construct the JavaScript AST, then we print it. Yeah. I think that does make sense. So this is the AST, not the Kast, the one, but JavaScript, right? So JavaScript, JavaScript AST is a JavaScript thing. No AI coding at all. No. No. I don't need AI. I don't feel like I need it. You're not planning to? I don't feel the need for it. I only sometimes talk to the LLMs to look up information, I guess. That's like how I use it. I don't use it to write code for me. Writing code is not that difficult. That's not the hard part of making the language here anyway. Sometimes you feel like behind when someone else is using it. You're a pretty experienced 10+ year full stack developer. I don't know yet. I mean, maybe I have not tried it much. I don't feel like I'm behind though, but maybe I am. I don't know. Like, I feel like I'm making progress fast enough anyway. So, like, if the AI writes the code for me, I still need to, like, understand it and something. Well, when I talk to the LLMs in general, like, when I do look up information, right, they lie to me all the time. So the question is, do they also write bad code all the time then? Because it probably is so, right? Like, why would they be bad at one thing, like, at, like, looking up something, but be good at writing code? Because, like, to write code properly, you need to look things up anyway. So, I don't know. I feel like they would suck, and you need to fix them all the time anyway. But I don't know. You tell me, you make a programming language with an AI, and if it works well, then that would be nice for you, I guess. Also, a lot of people just, I don't know if it's temporary or not, but a lot of people just don't like seeing AI in general. They hate AI. I don't really hate it, but I don't know. I just don't just don't care much, I guess. Currently, you use it for repeated code, especially when it understands your code base and the way you think. Well, that's that's the point of Kast, I guess. I don't want to see like the problem with the repeated code. Why does it even exist? Right? That's the question. If you have repeated code in your code base, that's a problem. In my opinion. But in order to fix that problem, you need a language which allows you to not write repeated code. So it should be expressive enough. How Kast will prevent that? Well, what's the example of the repeated code? I mean, technically, I do have some repetitions, I guess, maybe. But, like... I don't know. Like, for... Like the simplest example is that... like you maybe have the function that like prints something to like convert something to a string, right? Like in Java, you have the toString implementations, which are always written by hand, basically, right? They're present in code. But in comparison to that, in something like Rust, you just say derive toString, basically, and then the compiler generates the code to convert it to string for you, because that's just like the boilerplate, and there is well-defined rules of how that boilerplate should be generated. Well, it's not toString, it's the display debug, right? But that's like the simplification that I'm saying, right? So if something is boilerplate, then you can generate that code at compile time, right? As one example. Another example is having generics in the language, right? So like in C, if you have the algorithm that needs to work on both ints and floats, you need to write the function twice. Even in C, I mean, you have macros, right? But you can instead like solve that with the generics. Not everything is solvable with macros also, I guess, right? So yeah, like, I don't know, there's a bunch of different tools to help with boilerplate. What if you could generate your entire program logic and compile time based on an English prompt? Yes. I believe such projects already exist too. I remember seeing some language which literally does that. Anyway, AST. That's a higher level of thinking. I meant something else. But since you're actually doing it from scratch, totally respect. Well, I mean, yeah. In order to not think of the boilerplate, you need to think of a high at a higher level. Yes. Which is basically what like AI is doing for you, right? You give it the higher level thing, and then like the low level boilerplate details are figured out for you. But like instead of being the randomly generated code by LLM, like make it actually well defined is a better way, in my opinion. But yeah, I guess like it does take more time to well define the rules of how something should be done instead of relying on the output of an LLM and checking if it works well enough in like majority of the cases, and we just ignore the edge cases then or something. I don't know. Like, you need to think about the edge cases yourself. If you just let the LLM do that, then like you know, you lose the muscle memory of thinking. No? Okay, it's not AST. Hold on. We have in the AST of the JavaScript AST, we'll have expressions. We will have the I'd like to believe AI can be good at coding, and some people are getting pretty good with them, but not me. I find they're okay for some things, maybe writing tests. Yeah, I think like they can be used to, for example, to like when you have written your own code, like you can ask somebody else for like you can ask it to review your code, for example, and like see what it comes up with, right? And have some additional input. Maybe that is a good thing. Jokes on you are never think. Happy Nora. Welcome. We have already lost the muscle memory of keeping track of object lifetimes. Sometimes use them to design and research questions. But I also find that I spend extra time telling it what to do and fiddling with them. So verbose sometimes and miss lots of low-level details. Everyone knows thinking is bad for you. Yeah. All right, so we have a JavaScript expressions. We will have JavaScript statements. Right. Okay. Yep. So what do we need to generate? We need to generate the function, right? Which means that we need to define a variable. So like let, basically, let a variable, which is a string. Let's call it variable. Variable name is a string. Both thinking and typing makes you older faster. We say let variable and value is expression then, right? Okay. And then we have expression, which is right. So we need to like create the main function. So we say like let main is a function. So over here we say function, right? Which has args, which is a list of variable names, right? And has the body, which is a block, and the block is a thing which has statements, which is a list of statements, right? What other expressions do we have? We also have this statement, which is an expression, basically, which we ignore the result of, right? We have the expression, which is the application of the function. So function is expression, and args is a list of expressions. We have expression, which is just the variable. The refer to a variable. And we will also need to have the raw expressions, which like so that we can like insert JavaScript code. And this is just going to string. And I think this should be enough to do the... Maybe this should be enough. Maybe also expression should be like the string literal. Right? And this should be enough to do hello world. So here's my program. And we need to convert it to AST block, right? Basically, this is the top level block, which we will not surround in parentheses. Right? So we will return statements. Like this. Actually, like this is the top level. This is going to be my context. I will need the context of compilation. Right. I think top level is array list of statements. Let's do top level to be a block, actually. Because, like, of the way I'm going to do things. Top level. New block. So we now have the context, and we can go over the program. So we have program functions. So we have types there. Since we're doing the JavaScript, we can ignore the stuff. So we go functions, and we do array list into iter for function over here. Right? So every function needs to be compiled. Right? So we just say compile function. Function. This is the function definition, right? So arguments, result type, and body. So have compile function. Function is function definition. This should basically give me the expression. Not this expression, the JavaScript expression of this function. And this is the thing, right? So, okay, hold on. We have functions. This is a map from string to function definition, right? So we do, it's not array list, right? It's ordered map into iter, which means that we have key is name, value is definition, value is function definition, sure. So we compile the function definition, and we need to like assign, like let var name to be equal to compile function. So we will want something like this. Let var is a var ast var value is expression, basically, right? So this is going to inject it into the current scope that we are in, which means that we are going to have the current block, basically, that we are in. Block is basically the scope, right? So scope is another context type block, right? So we start with like this is the global context, and this is the local context, which is the scope, which is state top level. We're starting with that. Should this be like a mutable reference to block, actually? Maybe. Well, I mean, because we're in JavaScript, it doesn't really matter, but that's what we should do. So that's my current scope. And we are going to inject the statement into the current scope when we are saying let variable be value, right? So we say that statement is let var value, right? And we say current scope. We will take the statements there, and we say array list pushback statement. Right, so we basically, at the top level over here, are going to create a variable named name, which is the definition of the function compiled. Right, and that's all that we need to do technically. Then when we compile a function, let's see what happens if I press enter here to recompile. Oh, but on the error we actually stop. Oh no, we need to like not stop on the errors, I guess. Dot star. I mean, this error was reported pretty quickly. I need to like handle all of the errors and like if any of them happen. Do something. Is it in the cast lib over here? Right, so this is what handles all of the effects by default. So when we have the errors, we say handle error. So we continue with failure. I guess we can just like catch any exception during compilation, right? Can I catch any exception? Also, like, do compile. Do compile is basically try do compile with exception. Then we what do we say? Print exception. Like, how do I print it by like I want to use the default printer. Default uncaught exception handler prints the exception and backtrace on the std error. Right? So we just do this. And print exception get row backtrace. Like that is what I want. So I'm printing it.
log error. Compilation failed. It continues. Otherwise, we just raise the exception. Well, I mean, we just handle this exception only when continuous. Like this. Kast compile hello. Right, so if I go to the hello here, and if I make like an error, like print s here, it's going to say could not find print s in scope. We have like these things, and then, but then I can still recompile now, right? And it's going to not import the list because that is still imported properly. Okay, yeah, I think that is good. Okay. Catch errors when recompiling. I think there's one thing that we should care about is the cancel, because then we just raise cancel. That's a different thing. Next, like update cast. All right, so we are going to be able to compile compile function. Let's go with that, right? So we have function definition. Function definition has args and everything, right? So we need a new expression which defines the function. So this has the arguments, right? Yep. So we have function args is array list new, right? This is a list of variables over here. So we will return a function with args and body, which is a block. Let body is new block. And we'll also say with scope being the body now, right? So like everything that we compile inside of the function definition will be the inside of this new scope. Let's do the arguments first though, right? It's okay. We lose the ability to highlight code for a second here. I mean, this should compile, I think. It does not compile. Can find block in the scope, right? No, not flag update. This. New block. Block is not found in the scope over here. It's AST block, right? And this is going to be AST block too. Scope is body. Okay, so I need to say for arg in function args iterate, right? So we have argument name. This is going to be a variable, and args switchback arg, right? So this is the new variable with the name that we have in our minicast. Then we have the body, and with the scope being the body, we we say function body, and this is expression. And we will need to like return it, right? So I just need to say return this expression. We can just say like calculate function body, basically, and this is the result variable. And then we will also say insert statement return return var result var. So let var, this is literally called insert statement. Let's just over here maybe insert statement let var. I mean, I don't know, maybe we can have this helper still, right? This is the statement, and then we just insert statement. Insert statement is just where we push it to the current scope. Okay, yeah, I do have like the error a lot faster. Constructing mutable ref to non-mutable place. Right, this should be like what? This should be type. Yeah, so current scope is a reference. Now we need to reference it. Okay, this actually is much better in terms of like getting the errors. Could not find var in scope. Yeah, and then I never inserted the var. So like var is name string, and this returns ast var, which is just going to be name. But like maybe we need to like escape it because this is not a proper like JavaScript identifier or something. All right, also we have a statement which should be a return. We just return expression. Calculate. So calculate is we have expression which is from the intermediate representation over there, and this gives me the variable. So this is like calculates expression and stores it in a variable so that we don't like have too much nestiness, basically. Generated code, right? So we need to have the okay, let var is new temp var. I don't know. Let's say new a new variable temp, you know, const new var is prefix string so this is where we will have the context state. Var id is going to be an integer, so var id, let's call it next var id, right? And it's going to be equal to 0 here. So context is current context next var id plus equal 1, and name is prefix plus underscore plus to string context next var id or something like that. Or we can do it like here. And this is the name of the variable. Oop. Wait, no. So when we calculate, we create the variable, right? And then we want to... So this over here depends on the expression, actually, right? So we're going to match expression shape. Right? And I will return the var or something. Let's see, what are the expressions that we have? Currently, we have these things. Right, so if we have unit, then we just create the undefined, right? We don't care about this. I mean, actually, probably null is a better thing here, right? So this is the value, basically, you know? And then we say let var value, and then we return the var, right? Okay, so this is the expression in the JavaScript. So there's going to be raw null, string literal is going to be s. It's going to be also string literal s. If we have identifier name, then we need to have a var name, right? If we have a statement expression, it means a statement means that we ignore the result, technically, right? So, which means that we calculate the expression, the inner expression, and we ignore the result. So we do null. If we do then we are going to say basically let met result is raw null. I feel like maybe raw null should just be null. Let's have null there, and then we say, so this is the expressions for expression in expressions into iterator, right? We just say that result is calculate expression. Well, so yeah, this like introduces the new variables. We will do it like in this simple way where we have a lot of extra variables, just like we do in the current output. And then return result. So yeah, and this should be like variable calculate, right? Yeah, so we only care about the last one though, technically. If we have scope expression, it means that I need to create a new block. So we have an expression. Wait, how do we do an expression which is a block? Because we calculate it, yeah. We basically say something like this. We say let var first. Yeah, because like I need to create the variable first, just like declare it and then like assign to it from inside of a scope. And we will create a scope, right? So we have we will have a statement which is a scope, right? a scope block. Yes. Because you can do that in JavaScript, right? Right, yeah, you can. So we just insert statement scope block. Say block is a new block with scope being reference to block. This variable should be declared outside though. I feel like let's return then from here, because like by default we do this, but over here we have a custom logic. Yeah, so like we have this scope. Inside of this scope we are going to say well, I mean, technically, do I even care about this creating of the scopes? We do not. We do not care about this, actually, at all. Yeah, forget about this. We don't need that. We literally just say that we return calculate expression in our expression here. And then we have apply function and args, right? So we need to say that we say f is calculate f, and then we say that calculated args, or not calculated args, I guess, right? We will return the apply of the function with args. Well, I mean, yeah. Args is array list new. Calculated args. Let's call this instead IR args, right? And we do for arg in IR args into iterator. All of those arguments are just expressions, so we say args push back arg, but arg is a variable which is calculate arg, right? And then we have args and we have f. Okay, and I think that's like basically it, maybe everything that I have. Maybe it's done. New var, ast var. Ast var is not a function. Oh, because I say var, this is like the result var is what I want. So we say let var result var is this, and then we say result var, right? Yep. Otherwise I shadow the function that I'm trying to call. Over here. Oh my god, this incremental compilation is so much better than what we had before. Should have done that a long time ago. Also, like, I feel like I don't need most of the stack trace. Like, if the error was in the bottom, I would not need to scroll, maybe. Null, var, string literal. Oh, wait, I think I did not have a null. The stack trace is very gang-like. It's not like the real stack trace. It's what I'm compiling, right? So when I'm importing the minilib, and then when I'm inside there, I'm compiling this, right? And so like, oh, you mean like with scrolling up every time you see the error? Is that not in general the case in most languages? I feel like most languages do it like this, where they like. It's just like the way Rust prints the errors, right? And the way most languages do. I think not everyone is doing that. I think if you do it in Python, right? Like if you're in Python, you see like S, right? You see like you have the traceback first, so like where the error happens, and then what is the error, you know? So actually Python does it better, where the error itself is in the bottom, and then you can figure it out. And I think the stack trace also is like basically the actual thing is in the very bottom, and then like if you scroll up, then you like get the things that are higher up the stack. But in the regular things, including Rust, everything something that's higher up the stack is actually printed lower, right? So yeah, we could fix that, I suppose. Yeah, I think I just did not add the null expression here. Does the stack grow up or down? Yeah. It's like similarly with the trees. Like when you draw a binary tree, or like I mean a tree data structure in general. When you draw it, you have drawn a tree previously, right? Do you put the root of the tree in the bottom or in the top of the screen of the image? It's basically like, should the y coordinate, should the positive y be up or down? And everyone is doing it differently, right? Like some applications, including like I guess the terminal, says that like 0, 0 is basically the top left corner, and like positive y is, well, I mean actually in the terminal positive y, which is the second coordinate, is the column, so it's like x. And this one is like going down, but you know. And then like in OpenGL, the 0, 0 is in the center of the screen instead, y going up, x going to the right. Should put it on the bottom actually. There you can also draw the tree where the root of the tree is on the left, right? That's what I already do when I am like when you draw the like JSON basically, or the root is like basically on the left. Like if you do YAML, for example, right? Basically the root of the tree is on the left, in the top left, I guess. And like, you know, that's how you draw the yeah, that's how you draw like the file tree. So yeah, everything is just going in different directions. And it's all confusing because of that. In that case, it's actually Gang versus the world. You haven't seen anyone besides Math doing 0, 0 at bottom left. 0, 0 is not bottom left. It's only bottom left in this screen coordinates. But that's how OpenGL does it also. So I'm pretty sure I'm not the only one. Yeah, like the texture coordinates and like the screen coordinates are like that. But yeah, like I feel like in general, like it also makes it more consistent, right? Because if you had the screen coordinates y going like, it's not about like whether it's bottom left or bottom or like, it doesn't matter where the origin is. It matters what is the direction of the positive y and positive x, right? It's like positive x, pretty much everyone is doing it, that the positive x is pointing right? I think most people do that. But positive y is what is differs usually. Is it going down or is it going up? And we want it to go in the same direction in all of the cases, basically, right? Otherwise, it's not consistent. And it's like weird, and you will write bugs all the time. Which is also why, like, in the 3D, Like some people say that the up direction is z instead, but that makes it also less consistent because like y is supposed to go up, right? Anyway, we have expression which is null. And this should not be a semicolon. Calculate expression gives me a variable, so this should be like a variable. And by the way, this should just this actually should return. I don't need to do two variables here, so I can return this here. Yeah, so we calculate the value, and then we like over here. I'm creating the variable. Being NKS, it will be configurable. What, the direction of the y coordinate? Maybe you can you could say that coordinates is not just x and y, but it's an enum, like what is the coordinate system that you use, and then the coordinates in that coordinate system, right? You could have a more explicit API like that. Var is not expression. JavaScript AST var is not JavaScript AST expression. I mean, it does make sense, but why do you think that it is? Wait, why do you think that it is? That makes no sense. If I like comment this out, if people want to switch x and y, no, it's not like x and y are values of left to right. It's instead you have the like, you know, so like coordinates is, you know, either like the correct coordinate system, which is going to be like x and y, you know, correct vec, I guess, or, you know, like x goes up, y goes left, vec 2. You know, something like this could be done. Well, I mean, technically you have the transformations for that. So, like, you know, that's what, like, transformations, cameras are doing and things. Find top level in scope. And find ordered map in scope. block is not unit. And to return state top level here. Okay, it compiles. It compiles, which means that I can have the syntax highlighting again. But cast mini. Okay, but we're not calling this code, right? And also I have commented out some things. I've commented this thing out, which we should uncomment. So it's like basically it looks like the times for me is about 2 seconds to get to the error message, but when I do compile, because code generation takes about 10 seconds, it seems. I didn't think that my code generation would take this much time, but okay. Well, I guess I am generating 100,000 lines of JavaScript at this point. Okay. Which means that I think when we go through the minicast, it's going to take so long, actually. So if I do this, then we're going to have the completion error saying that var is not expression. Boom, 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 boom. Anyone sees the error here? I don't see the error here. Oh, because return calculate. No. Calculate returns the var. Yeah. So like, this is correct. Result is var calculate. Oh. Because var is supposed to be a var. No, but this is a var. Yeah, this is a var. Hold on. Let's just comment out some of these sections and then see if we still have the error. Var. Oh, we have a variable where we store just AST expression for some reason. Var returns AST var, yes. So wait, it's probably like the apply, right? If I was to guess, which is faulty. Yes, that's it. So the error is over here. So say f is calculate f. This is a var, right? AST var. Let's maybe do the type annotations here. The args is array list of. Yes, I see the error, right? Because the arguments are supposed to be expressions, right? But this. Oh wait, no, but it is an expression, right? This over here. Expression is var. Wait, what happened? Oh, I was killed? I think... Oh, okay, that makes sense. I think I ran out of RAM. I'm giving it maximum of 5 gigabytes of RAM. And because... Yeah, that makes sense. So we have like the incremental compilation, but every time we incrementally compile, we do more RAM. And it eventually dies. That's okay. Because f is AST var, right? F is var f. That's why. Right? That is why. Okay. Now it's supposed to compile. It does compile. Okay. Let's do this. Let's have the command line mini cast, right? So we have cast mini. This just compiles basically, right? So we have a program which we are just printing. I don't care about printing here. Let's instead say root scope mini backends JavaScript compile program, right? And this is the JavaScript. So this is the JavaScript. What does it return? Compile. It returns a block. Maybe this should actually. I don't know. Let's say right here compiled. You know, we will say that compiled is a you know, top level is the block. Maybe we'll have some other data for this stuff. And then we will say like print, and we will print the compiled, right? Okay, so this is where we say output is current output. And we say like AST print block compiled top level. No, I don't want to print the block. I print statements basically. Top level statements. Right? Like this. So here's my AST. Let's have a print here. Okay. Statements. A list of statements. We have the current output. We just do for statement in statements, and to iter we say print statement, and we say output right semicolon /n, right? And that's all that we need to do. When we print statement, we're going to match self with okay, we have expression, then we do something for personal project. How much line of code do you consider massive and maintainable? I don't know. I feel like none of my projects have exceeded like 30,000 lines of code yet. So are these massive? I think not, right? Like I started the self-hosting not so long ago and I already have the 10,000, 11,000 lines of code here, right? Which is basically like 1/3 of my biggest project. I mean, it like depends, right? Like for example, for my game that's on Steam, that you should guys wishlist, by the way, we have like it done with a custom game engine, but I consider a game engine a separate project from the game. If we combine those, then it's maybe like, I don't know, 50,000 lines of code. I don't know. Maintainability, I think, is not about the lines of code, though. Maintainability is about like splitting things
into like small contained modules as much as possible, right? Kind of. So like there's the game and then there's the engine, right? Those can be treated as separate things basically. So you need to maintain them separately. And the engine is like consisting of multiple parts too, which you can like, you know. Is it to write a couple hundred lines of unmaintainable Python code? Yeah. You follow a metric at least for Go and Rust personal projects for the moment. You exceed 40,000. It should at least across 150 or 300 files for modularity. Wait, hold on. 300 files, 40,000. Which means how much per file? Hold on, my math. Let's open up calculator. 40,000 divided by 150. It's 260 lines in a file. That's really small files. I do like this number though, yes. If you can keep your files this small, that is good. For sure. Although in Go, I guess, the files are like different. Did you alias calculator to node? Yeah. Well, I was using the Python before, but I realized that JavaScript is actually better as a calculator because it like gives you the preview. When you say 2 plus 2, it gives you the preview of the result actually over here already. That's like a good calculator actually compared to Python. Or I don't know. Maybe there are other better alternatives. You have 157 files for 30,000 lines goes in CTL. I mean, wait, does Toki says amount of files? It does say, right? Oh, 69 files. Nice. So I have 69 files and 11,000 lines of code. So, which is, what again? 11,000 divided by 69. Wait, this is like exactly the same number. 159 lines, like, so I'm basically following your metric. Although it's not like really about the files, right? Because in Go, the file, like splitting the files still means that it's all in the same package. And basically, I would consider in Go specifically, like the package is the alternative of the... So because like the package is basically the compilation unit kind of there, because everything in the package can refer to each other. So it's all spaghetti. So it's like it's all potentially spaghetti, right? While at least like over here, what I'm doing is that every file is like importing the other thing. Import is the thing that disallows circular dependencies. So every file, when it depends on something else, you know what I mean? Like, there is no circular dependencies, unlike in Go when you split your package in multiple files. Pum, 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 pum. I mean, maybe I'm doing it somewhere. I think I'm doing it actually in the LSP over here, because over here I'm not importing but including instead. But this is just like 10 files, and I think these also can be imported instead. I don't know why I did it here. Anyway. Print expression. So when we... Okay, hold on. Here is my thing, right? We have expression, we have let var value
we have scope block, we have return expression. Okay, so when we return, that output be current output. Let's see, over here, output, right, return, print expression. Printing statement does not require semicolons. Yeah. When we print the scope, we write the opening curly bracket, the closing curly bracket, we increase indentation, /n here, /n, output, right, /n, decrease indentation. I mean, this over here prints the new line every time. So I don't need this, actually. We increase indentation, then we print statements. And this over here is going to be called print block. And block is this. Do you use effect for local logic? Yes, or just external state like output? I do use, yeah. No, I mean, I don't use effects, right? Like, I use like the simple form of effects, which is the context, and like, which don't alter the control flow, right? So, like, for example, over here, right, I have the state. This is the state of the compiler, right? So I say calculate expression. This basically is a function that is called in the context of compiling to JavaScript, right? Which is, like, for example, when I say, like, let var, right? I'm inserting the statement. Where do I insert it? Into the current into the current scope, right? So the current scope is also done with the context system here, instead of threading this through like you would in Rust, I guess, right? So yeah, I do use this in a bunch of places, I guess. But yeah, also output, error handling is done like that, where, so like error handling is where like I basically say like report the diagnostic, which is the error, and in that case it is going to like either like unwind and like I guess like stop on error if needed, or just report the diagnostic and continue, because like we can configure this behavior. Would be nice to get an overview of the use cases later. I don't know, I feel like this I mean, yeah, it's error handling and like it's literally the context. That's why it's called the context system, right? Like the only thing that I'm not doing is the like, yeah, we also use it for panic handling, by the way, in the Kast standard library. If you want to handle the panics, there is basically the default panic handler, and you can like override it, because like panic handler is just a context, right? So you can actually like not crash on panics, and you can inject like this locally, which is what you do with like catch and wind, I guess, in Rust, if you want that. But yeah, panic hooks. Right, like in Rust, the panic hook is global, but we do a local panic hook instead, basically. Yeah.
So the only thing that is like left to test is the like because I actually never implemented the delimited continuations in the language yet, which means that we cannot do the like async stuff. And I do want to have async because my language server actually right now, I guess, it could use this because we are actually processing every request synchronously, but we could instead like like LSP is the thing that actually needs asyncness, but I don't know. I just feel like it's working good enough as is, so whatever. Not crashing on panic sounds like something like try block, yeah. Well, I mean, panics in Rust are already just an exception. You can already, like, catch them. Like, yeah, panics are literally just exceptions, yes. So the only, like, difference between panics in Rust, I mean, in the future of Kast, right now I don't do it, but we're supposed to have these annotations on the functions. Can they panic? Can they do, like, this thing? Can they do that thing? Right? So, like in Rust, you treat every function as it potentially can panic, but we are supposed to have that in the type system. But right now, not. But in the future, which is basically the effects, turns it into the effect system, which people in Rust also want. I'm pretty sure. I'm not sure if Rust will get it eventually. Maybe. But it's probably not very soon. Maybe like in 10 years. What was I doing? I was doing the printing, right? Yeah, definitely not in the next edition. I don't know. People just start talking about it, like this and previous year, I think. Like the Rust developers, they were aware of the thing that is called the effect system, but they were trying actively to come up with a different solution. So there were like initiatives like the keyword generics, if you have seen that and stuff, right? But as I understand the latest development on the topic, they actually basically coming up with an actual effect system. I think. Well, they're not coming up with it yet, but like they're talking about these things, you know? Like the grand vision for Rust, if you've seen this blog post. This is, I don't know, like, is Joshua Watts the one of the developers of Rust? I'm not sure, actually. But yeah, basically they say that they want the effects in Rust. They want substructural types. So we want linear types in addition to affine types in Rust, where you must use a value, and if you don't use it, it does not get dropped automatically. You must do something explicit with it. And you want to have refinement types too, right? Is Joshua Watts core Rust developer? I don't know. Josh is a developer advocate at Microsoft for the Rust programming language. Yeah. Bum 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 bum. You just broke your backend due to you wanting to call C functions with structs, and the C ABI is evil. What's evil about it? Yeah, I don't know. I mean, I'm not like aware of the details, but there's like a specific ABI. What exactly you're
You're saying you want to call C function with struct, so you replace all of the arguments with like a single struct instead. But that's not what they call in convention, I guess, basically. Because you are supposed to like put some of the arguments into like registers and things. And I think it also depends on the operating system. Maybe. I don't know. Or is that like the C ABI versus like I don't know. I don't remember much. I rarely touch these topics. Block. Block. Return. Let expression. So when we do a statement which is expression, we literally just print the expression here, right? So we say print expression. Okay. And then when we say let, we say output write let, and then we say output write a variable name, and then we say output write, no, then we say, yeah, we say output write equals, and then we say print expression value, right? And then when we print expression, the rules of all the struct passing is not as simple. Structs can be split so that each member is an argument at least sometimes, and the return values are just as strange. Oh, it's because like you're doing the low level, like you're not transpiling to C, right? You're trying to interface with C, and you're generating like assembly code or something, which tries to call a C function. And like you're not going through LLVM or something. Don't things like LLVM solve this for you? I need to like surround the expressions with parentheses. I think I will surround every expression with parentheses for now, just like I'm doing in the OCaml. Even although it's not always necessary. So the string escaping potentially should be different for JavaScript actually here, but it's probably fine for now. If it's a variable, we just try the variable name. Function f function args body. Okay, this is going to be output right opening right closing for I arg and args into iterate enumerate. If I is not 0, then write comma. Output write argument name. This, that, And then print block body. Okay, and then when we apply function in args, print expression f, right opening, right closing, for I arg in this, comma, print expression arg. Okay, I think this is all. Let's have the other terminal in the other tab like this instead. Yeah, so output needs to be imported. Raw s. Match branch semicolon. Array is not a function. Statements. Array list of statements is not the function. This is a better message, I guess. I'll need to like change the inference or something. Like I don't like my error messages. They're pointing in the wrong places, right? Like the reason this is thought to be a function here. Why? Oh, wait, it's because this over here is a function. Hold on a second. Yeah, because like this is called statements and this is called statements, right? Okay, it's because this over here. It's because of this over here. See, I'm saying print statements, statements. And this statements refers to this statements because this is supposed to be block statements instead. So this basically leads to the inference thinking that this function takes itself as an argument and like it breaks things. So like the error is actually like over here instead of over here, right? Because I'm like inferring the type over here, but then over here I'm checking it against the annotation. And this like fails over here instead of failing over here. Alright, do you guys think it's going to be the proper JavaScript? It's compiling my mini cast. Can we do a hello world? Kast mini. Nothing is being printed. Wait, do I have it in the CLI? Wait, yeah, we have the Java, like, this is the compiled program, right? And then I need to say root scope mini backends JavaScript print compiled. Right, there we go. I forgot to print it. Maybe I can look at the code generation. Like if generating JavaScript after I have compiled the things takes this long, that is like different, right? Like why does it take 10 seconds for me to write JavaScript? I mean, I understand that it's 100,000 lines of JavaScript code, but like how big is that file? It's not that big, right? It is 3 megabytes. So, I don't know. Maybe I'm not doing buffering or something. I don't know. Probably not the case, though. Okay. Hold on. Look at this. Look at this. This is JavaScript. Hold on. This is print. This is main. I guess like, so like I'm just creating something with the main function. And if we are doing the JavaScript, we need to like call the main function here, right? So we need to technically do what? Like when I'm compiling the program, maybe like if there is a main function basically in the program, then I should also call the main function, right? Automatically if program functions get main is some, right? Then do we need is some function if we have this, by the way? Maybe then we can say then we say insert statement, which is expression, which is apply, which is var main. Apply function is var main, and args is just an empty list, right? Let's do this. So then we can just pass this into the node and we will be able to print hello world. Right? I need to like get rid of the colors though. I need to detect that if I'm piping, then I don't need the colors. There is like this vertical bar and stuff. You know? How do I do this? Is it in main? Right? Do we change the color? Yeah, we do have color. Here. Do we say color false? This is in the common arguments, right? Just say color, and yeah, just say color false. Cast color false. This still does the vertical bar though. I also have like these logs which I think I can get rid of. This is just in the mini compiler log info. Let's do debug here instead. I don't care much about this. So how do I do the how do I get rid of the vertical bar? It's like if we don't have the color, technically too, right? So that's part of the output. Okay, this is going to trigger massive recompilation because everything depends on the output. Yeah, so like indentation string is this. Color is true. Like if I... If I want to be able to change the color, and this should result in me changing the indentation string. Ba-da-dum. Maybe maybe we will do like color here, new std output, color boolean. So we just do the color here, and indentation string is going to be is if color, then we will do this vertical bar, and otherwise we just do the 4 spaces, and that's it, right? New std output. It's only like called over here, right? Color is true. Let's make this a named argument. And then you can just like overdo it. I mean, I can like, yeah. Basically, like we initialize the output twice. First, like in the beginning, and second after we have parsed the arguments. I'm not sure if I'm printing something like while I'm parsing the arguments, but in case we do, you know, I want this. So color in this case is going to be basically common args color, right? There we go. Let's see. Recompile. This is going to take 30 seconds. Because output was changed. And mini compiler was changed. And we ran out of RAM because that happened, so we need to restart the building. Any such cases? That means we need to get more RAM. I can give it more RAM. I'm restricting it specifically to 5 GB. Just in case, because like sometimes I do something and like I use all the RAM, the entire PC starts lagging and shit. Maybe I should like set up swap or something. I don't use swap. Then like it's not going to be as bad. There we go. So now we don't actually print any colors in the output, right? And then we just say over here, and then over here we just say node. There's no hello world. Let's take a look at the code here. So we say main. We have print. Oh wait, because temp4 is null, and we return temp4. Wait, what is this? Print. Let me take a look. It's because I'm not doing the native things, probably, right? Or where's my test? Mini test. Over here, we say print hello world. Oh, because print is literally just doing nothing. Okay, that makes sense, right? So how do we make it print? We basically we need to talk to like the backend, so we need to have a native expression, and we will do like console log s. That's what we want to happen here, right? Basically. Yes. So I need. So in the intermediate representation over here that we like are going to convert to JavaScript, we need a new kind of expression, which is the native expression, right? And this should have the parts. Okay, let's call it native expression. Native expression is a thing which just has parts, I guess, which is a list of native expression part, and native expression part is basically either raw string, right, or it is like interpolated, basically. And in this case, we just do the expression there, right? So in the JavaScript, what we're going to do is when I'm compiling, calculating an expression, right? We know that if this is the native expression with parts, right? Then we are going to return a native expression with the so this is IR parts. We will return native parts. Parts is new for part in IR parts, and to iterate. Part is match part. If it is a raw part, then it is raw, and if it is the interpolated expression, then it is going to be interpolated calculate. Actually, when do I calculate this thing here? Yeah, I guess I do yeah. So like it just needs to be thought of when I created the native expressions that they're not all going to be calculated in place, but before. And like it's the result of that expression that is being passed in there. Yeah, a little bit. That's okay. I guess, which means that the raw expression. I was doing it something different in my OCaml, right? What was I doing in JavaScript transpiler? If we have a native expression, we have parts, we calculate. Oh, we have a raw list. Yeah, we have a raw list of expressions. Yes, I see. Yeah. It's the same behavior, basically. Yeah, we don't say like interpolated. We instead say that, yeah, like it's not like native, but it's basically, yeah, it's like a raw list, which we basically concatenate the things. A raw concatenate maybe is like the better name than, which we are concatenating other expressions there, which is either a raw expression or just like this variable, which is the result of calculating the interpolated expression then, right? So the AST of the JavaScript can have like the raw concat where parts is a list of expressions, like this is what we can do. And then when I print it, right, I say if it is a raw concat parts, then we just like literally print them in order. So for part in parts and to iter, we just print expression part, and that's all that we do here, just next to each other. Every expression is going to be printed, right? And in the mini compiler, if we see the native process, no, it's native type. Yeah, I need to like see if bum 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 bum. What? How does this work again? Process function is this, right? So yeah, we parse expression, which is that. So now we have a new expression called native that I will have to do, right? So if rule name is native, then let's say that so we need to have like an interpolated string here. That inner is root st helpers syntax of the mini cast. What is the native? We just have the underscore here, right? So we just expect single child with no name. So like this is the inner, right? Yeah. So we say that if inner shape is interpolated string, there's either an interpolated string or a raw string, by the way, right? Which is two things. Interpolated string parts then we do something, right? If inner shape is just string, then it is that. Let's just say this. Let's say mat parts is array list new. So I'm going to actually match inner shape here. It is either the interpolated string or string. If it's anything else, then I kind of want to do the error. Right. I'll print the diagnostics here. Expected as string. On the inner span. If we have string as, this means now. What does this mean? All right, so we have the parts, right? Parts. This is just going to be a row, right? So we say mod parts. Push back a row contents of the string. If we have interpolated, then we like say for part and parts into iter. We match part with so the parts in the interpolated string. It's either content or interpolated. In content case, we just do same as in the simple string. And if it is interpolated, AST is, yeah, this is like the inner AST, right? Then we basically need to add the part which is interpolated, parse expression AST, and we don't know the type here, so it's going to be none, right? And we need to, yeah, like that, right? Okay, let's recompile. Yeah, this is a different parts, right? Like this is the native parts. Right, so now we have the native parts, and what we're going to say is we're going to return the type. So for the native expression, actually, what should be the type? What should be the type? It's basically going to be the expected type, right? But in case of a semicolon, we don't have expected type, so we say option unwrap or unit. So like we are going to default the native expressions to units then. I think that's okay. So shape is native, parts is native parts, right? Couldn't find F in scope. Expected a string. That's all that I do. Maybe like a native string. AST is not string. Because this is like a token where shape is string. Right? Parts. Okay, it compiles. Console log is not a function. Hold on a second. We console log and we call it with the string. Where's my test? Mini test. Console log s. Okay. Can I do Can I do cast lex? Tests mini test mks. I was pretty sure that, yeah, like, okay, yeah, no, this is correct. What about cast rule set source mini syntax parse rule set this, right? So yeah, we have interpolated, which is a console log interpolated as, and then yeah. No, this is correct. It means that I'm not doing something else right. It is parsed properly. Cast mini. So this is just well, I mean, the parentheses are still all correct, right? So what does it look like here? We are opening console log. Like, it's an extra closing bracket here for some reason. And an extra opening bracket over here. Oh, wait, I know what happens. It's because every raw part is surrounded with parentheses. Yes, this is not correct printing over here. So when I print expression over here, when I print expression, when I say the raw concat, if this part is raw, then I guess I don't need to surround it with parentheses for sure, right? Because otherwise, yeah. How about this? If part is raw, then we just output, then we just output right as, right? And otherwise, we will actually print it as an expression. Right? Yeah, that makes sense. Hello, Diego. So there we go. Now we'll just console log properly, and we can run it through the node. And oh shit! Oh wait, it's because I need cast color false. We should like detect though. But there you go. We have a hello world. Hello world is printed, right? Hello world is printed. Okay. So we can now do a bunch of things. Hello JavaScript. So yeah, like generating this for this simple language is pretty simple so far. We are going to add more stuff though, right? Because I will still need to add references and unwinding and maybe like some other things. There is no async here yet, which I think like we will still keep the minicast implicitly async, right? Yes, I will. So yeah, we have like a much simpler type checking. No generics. Boom, boom. Maybe I like since whatever. console log, yeah. Should I maybe like try to write the transpiler to minicast first? And that way, like, we will see all the features that we need to implement here, right? It's actually, yeah, it's like, yeah. So I need to like copy my JavaScript transpiler, remove some of the things. It's supposed to be even simpler than the JavaScript transpiler that I have currently. And then we'll see what we need. But yeah, we will need unwindable blocks for sure, and references. Those are the important things. Anything else? Maybe not. We'll see. Should we try to write some program here? What is the program that we should write? The Fibonacci numbers? Let's do the Fibonacci numbers. Let's uncomment this. We have Fibonacci, add, sub, less, right? So we don't have operators in this language. We only have the functions, right? So, but we can just have the native like this. This is supposed to type check here easily. So we have the Fibonacci, and then we can do like, so we can do like print Fibonacci 10. This is not going to work, right? It's supposed to not work here. It's supposed to say, yeah, we have the compiler error. Wait, am I putting the compiler error to the std out, actually? The compiler error should go to the std in, right? To the std error, right? So we expected expression. Oh, we don't have ifs. That's right. Okay, let's do an if. If is important. Let's do an if. If rule name is if. Syntax. What do we have? We have if, and we have if without else, and those are like separate things here. Sure, whatever. So we have if, there is condition, then case, and else case. Let's just, you know what, let's return. Nah. No. Yeah, let's return parse if root expected type root. If rule name is if without else, we also parse if. I should like extract these other things to functions too, technically. Parse if is expected type is optional. Type root is the group. This returns the expression. So say condition is root children triple named condition. Expect child unwrap child value. Condition then case. else case. So else case is optional, though. Else case is optional, which means that we later map it with child into child unwrap, like this. Right? So we have expression. Let's see, expression shape. We need to have an if. We have condition, which is expression. We have then case, which is expression, and we have else case, which is an optional expression, right? So we return. No, this should return like shape and type, not expression, you know? Or let's call it parsed expression. You know? Parsed expression is just shape and type, which it's like, if I have the, yeah, so shape is if, condition, then case, else case, and the type. We'll need to figure out the type and everything, right? So so type is if else case is the some else case. No. Hold on. We need to basically first compile the then case anyway, right? Right. So let's say that then case is, no, we need to first compile the condition, right? Condition is parse expression where expected type is Boolean, right? And this is condition. And we say then case is parse expression which has the same expected type as the entire if statement, right? And the then case, right? And so like now we have potentially more information here. We have the actual then case, and we say that so type is equal to then case type technically, right? And then we say that else case is else case map else case is T, I guess, right? We just say parse expression, which has the type which is same as the then case, which we have already inferred. So it's like some then case type and ASD, right? That's what we want. Okay, and then we need then JavaScript to also have, so JavaScript if is a statement, if condition expression, then case is going to be a block, and else case is an optional block, right? So to have a statement, it's an if, condition, then case, else case, we write if, we must open the round bracket, then we need to print expression condition, right closing bracket, print block then case, and then say if else case is some, then we write else, and we print block else case, right? Okay. And then when we calculate the expression, which is an if, condition, then case, else case, we need to say that so I need to insert statement. Like in this case, it's actually like a little bit different, right? This is the variable, right? So I need to actually first declare the variable, which is the result of the if expression, right? Yeah. So we say that result var. What do I return here? AST var, right? Yeah, I just return result var. Result var is new var, which is like if result, right? So we insert statement if condition, then case, and else case. But we say that condition is calculate. Yeah, we need to say condition is calculate condition. This is expression. So condition is variable condition. Right? Else case is variable. Then case. Like this is supposed to be a block, right? So calculate calculate block, basically, you know, then case. No, it's not like calculate block, it's a little bit different. Like we do something like this. Block is new block. We say with scope equal to the block, and then we like calculate the then case, and then we basically need to assign. We need to assign to the result var. I need to assign the calculated then case, right? Like this. So that's like the end of my block. And then I return this block. Right? And else case is something similar, but we say that we're going to, like, I guess, let's match else case. If it is some else case, then we'll do something similar. If it's none, then it's none. But we will do the similar block, where we assign to the result variable the calculated else case, right? Yeah. Also, I guess like then case, like we don't need to assign the result variable if the else case is optional, but that's okay. We don't care much, right? Yeah, so we calculate those things, insert the statement, and do these things. I think this is all. Let's see if it compiles. You can find assign, right? How do I assign? It is similar to the to the let var, assign, we only assign to a single variable, value is expression, right? So we just insert another statement here, which is just, instead of let, it's assign, which, yeah. So we have another statement, which is assign. And when we say let, we say let, and we say assign, we just don't say let, basically, that's all. It's compiled. Is less not found in current scope? Yeah, because it's called less and not is less. Right? Expect expression got 2. Okay, we don't have the literals, which are number literals, right? So that's another thing that I should do. I mean, what we can do, actually, we can easily just say like native 2. Then I like don't need to like figure out the types, right, and stuff, how to convert these things, because this is just like how you write this natively or something. I don't know if I want this or not to be in the language. Right? Expression got 10. So this over here is going to be also native 10. Expression string got in 32. Yes, so now this doesn't type check because the Fibonacci is an integer and you need to convert this to string. Right? How do you convert strings to integers to strings? To string 1, 2, 3. Object undefined. I don't know what to string is. I forget how you use it in JavaScript. It's just x.toString. You just cannot do it directly. You need to like say 1.toString in parentheses, and without parentheses it doesn't work. Got it. Yeah. So we say that toString. Well, we can call like int 32 toString basically, right? And this is going to be x int 32 return string, which is native x dot toString. Like this. Hello, penguin operator. You're back. If result 3 is not defined, wait a second. If result 3, this is when we're doing the Fibonacci, right? Oh, wait, hold on. If, wait, the if is not even here. What? How do we do the if? Where is the if? lost if result. We calculate condition. We calculate this in a block. Calculate this in a block. Like I inserted the statement and it was not inserted. Feels like a bug. Because it was inserted in some other scope or something. Or am I not printing it? No, I am printing it, for sure. So what's this? Where was this inserted then? Fibonacci, if result. I don't see any ifs anywhere, right? It got lost. Is this a bug in the what? I'm using insert statements all the time and they work, but not this time. Well, I mean, maybe it's because I'm overriding the scope here, but this is supposed to only be local anyway. But is there a bug with local scopes? Oh, wait. It may be. Oh, wait, hold on. I see it. I think. It's because over here we have the scope. Yes, this is actually the miscompilation of the bootstrap. Here's the little test. Playground test. Right? I can have the code, which is like, you know, we have like context, which is, let's say that we have the context, which is like just an integer, right? So we say that with context be equal to 1, 2, 3. And then we say a scope with context be equal to 4, 5, 6, right? And then we want to have the function called print context. Let's just say called function f, which is just going to dbg print current context, right? So like, what is my current like integer basically, right? We're going to call it here, we're going to call it here, we're going to call it here, and we're going to call it here, you know, in a bunch of places. So if I say cast playground test, this is the interpreter. This is going to say 1, 2, 3, 1, 2, 3, 4, 5, 6, 1, 2, 3, right? Because like in this inner scope, only this function sees the 4, 5, 6, everything else sees the 1, 2, 3, right? But if I do this with the JavaScript, then we're going to see 1, 2, 3, 1, 2, 3, 4, 5, 6, 4, 5, 6, which is incorrect. That's because I actually lose the parentheses, because it is similar to what I'm doing in my self-hosted JavaScript compiler, where we just like calculate the things. And when we see the scope, we just calculate the scope recursively like this. But there are potentially some things which are scope specific. So it's not like that, right? So I need to like actually see, is there anything like, I mean, we can always create a scope, I guess, but let's try to not create the scopes too much. Right, so there is going to be actually an if Like if I actually need a scope for expression, then we do one thing. Otherwise, we just return calculate expression, you know? So if we actually need the scope, though, then we are going to do something very similar to the result var. So we are going to say that scope var is new var scope result, you know? And then we're going to return scope var, which we're going to assign into by creating the scope over here. And block is new block, right? So inside of this block, we are going to we're going to calculate the expression. And this is scope var. I mean, we can call it result var. It's okay. Like with the if. So we do this inside of this scope, and then outside of the scope into that scope, we insert statement, which is a block statement, which is block, right? And then the result is inside of the result var. But we need to do this also in my bootstrap, right? So we have expression scope, right? Yeah, there we go. To do JS scope, we even have a to do here. So we need to do the same code now in OCaml. So if actually need scope expression, then we do one thing, otherwise we do the other thing. Actually need. So we say calculate expression. How do I do this here actually? I'm not sure. Let's see an if maybe. Yeah, we say like let var result undefined. We need to do something like this here. So result is, this is like the scope result. We start with undefined. Oh, by the way, yes, we need to like assign it to the undefined first, because it should be like outside of this. And same with the if, right? Same with the if. I need to say basically let var result var to be equal to undefined. And say with scope let var result var undefined. Do I actually have undefined? Undefined. 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 So we execute, no. Scope. Do I have the JavaScript AST? And do we have this statement, which is a scope here? Yeah, we have block. Okay. Yeah. So yeah, we execute the block, which is the scope, where we assign var expression, right? I think that's all. And then we need to actually need scope. So how do we define this? Actually need scope expression boolean. So we match expression shape. Destruct. All right, let's see. The error false. Target dependent. That's target dependent. It's more like this expression. It's a little bit like weird. How about we don't care about this? Like, is it going to be that bad? Oh, what if I just say actually need scope expression boolean is function which returns true always. Let's just do that, right? Like, it's going to work, right? No, it doesn't work. Hold on, wait, what does not work? What's the thing? What do we do here? Scope result is this. Wait, I say context. Wait, hold on. You don't have. Hold on. Do you have? Do you not? You do not have. Do you have shadowing in JavaScript? I need to actually shadow this thing here. You do not, right? Which makes this a little bit more annoying, which means that I need to like actually have a new variable for the context. So in the current like scope, we might need a different context variable, which actually, oh wait, hold on. But then like I just need a new context variable in the scope, and I don't need to like actually introduce the curly brackets technically, right? Yeah. Yeah. I actually don't need the curly brackets. I just need to save save my context variable. Right? Which basically is whenever I define a scope. And the first statement here is going to be that we introduce the context variable from the parent scope. And we have this effect here, get scope. So scope as a type should have the statements and the current context variable. So we don't have context variable, which is this. It is specific to the scope then. Context variable JSAST name. Yeah, I think that's what we want. So we don't have context var. We say effect perform get scope context var, right? So it's context variable of the current scope. And when I create the new scope, I say context var is generate name context. That's what I do. So yeah, and also there's like the parent scope here, right? So we will say parent scope is get scope, and we will say that over here we are going to do f, but we're going to also first say let var scope context var is just equal to var. I forget how to do this here. How do I get like the var? No effect expression, no effect AST shape. Span. We don't care about the spans. Shape is var. Parent scope context var, right? Unless we say that it's the root scope, which by default is false. Are we self-hosted yet? Well, I have done the hello world, yes, and now I'm trying to do the Fibonacci example in the minicast. How do you choose which subset of the language to implement for minicast? Because I know how I'm transpiling to JavaScript, I basically, like, the plan is to switch from the JavaScript backend to the minicast backend, which, like, is supposed to be, like... So, like, we have calculated things at compile time and, like, all of that stuff. Right, so, like, only the minimal stuff that is required. So that... Well, like I'm trying to abstract over multiple backends, which includes, I guess, like, basically JavaScript and Golang currently is the plan, right? So we allow, like, usage of garbage collector, lambdas. I'm using exceptions for control flow in JavaScript. So, like, that's like the unwindable primitive in Kast. And yeah, something like that. You know? Like, I think before maybe moving forward with minicast, I need to actually, like, figure out what I need, right? By making the transpiler to minicast, which should be relatively simple, because it's going to be very similar to the JavaScript transpiler, but it will require the type generation too, I guess, right? Because in JavaScript we don't generate the types. Yeah. And then when we like do lower level stuff, I'm not sure if like for the lower level I will create the microcast or not, but that's a possibility. Like when we also resolve the lambdas, we like where we assume that we have a language which is low level basically, which is our target, which can like do jumps, go-tos and things, I guess, and raw memory access. Because in Kast we don't have pointer arithmetics, but like when we compile down to the like lower stuff that's needed for things, you know, so might require like some extra stuff. I don't necessarily like need the front, like for the minicast I will have this like as text, right? This representation as text is technically not really necessary, right? It just means that I can like test it easier. This could be a bytecode instead. Is unsafe interrupt gonna look anything like Rust's? What do you mean unsafe interrupt? You mean like unsafe, or do you mean... Well, I mean, it's supposed to be something similar, I guess, but not exactly, because I'm trying to abstract over the backends once again, right? But yeah, colon C, yeah, I suppose. Well, I mean, it is required to be able to do that, right? It depends on the target. When we transpile to C, then calling C will be just similar how I'm doing the JavaScript here, right? We just have the native expression, and this is basically just embedding the C code into the result file that I'm generating, right? When we're doing something, then like when we not transpile but actually do LLVM, that native expression will mean something else, like however you call C in LLVM or whatever. Right? I guess this is not going to be a string, but some structured stuff, maybe. Right? So basically we have this native thing, which has the meaning which dependent on the target. And we have conditional target selection also because of that. If that makes sense. So like you're thinking mostly in the context of writing SDL wrapper. Well, I mean, I already have made the wrappers for, not for the SDL, but like, because we only have the JavaScript right now, right? For the like WebGL, I've made games with it, right? It is going to be something similar, but like, I mean, before I can, you will have to wait, I guess. But if you cannot understand what it looks like based on the JavaScript example, but it's basically the same, right? For now, the plan is transpiling to C, and we are going to just embed these C expressions directly. So in order to create the SDL wrapper, you have like your own function, which is like SDL wrapper, and inside of it, you will have the native expression, which calls the actual SDL function, right? And technically, all of that code can be generated at compile time by parsing the header files and like stuff, you know. But that's another thing. So I imagine there will be like a binding generator, which just parses the header files and generates the SDL binding for you, basically. And same is planned for the JavaScript, where we parse the web IDLs instead to interact with the web APIs. Which is what Rust is doing already. And it's great. And bind gen for C also is done like similarly, I guess, in Rust, right? You can just generate your own bindings from a header file, I think. I never done that in Rust. But yeah, you can always do like the low-level stuff yourself or use the generator. Anyway, what we're doing... I'm fixing the completion errors here. Parent scope. Yeah, so I do this only if root, then I'm going to let var, and parent scope here is going to be option unwrap. I cannot calculate this here because this is inside of this. So yeah. Otherwise, in the root scope, the context will have to be like created. Okay. So what is this? This is me calling, and yeah, this is just going to be the get scope context var. So this is inject context, right? Current context. Current context is just get scope current var context var, and this is me mutating the context just for the current scope. I think this over here actually, like, since this is injecting the context, shouldn't this create a new variable instead of mutating? Yeah, I think it yeah, it just create a new variable, that's all. We don't assign. No. We create a new variable, and then the context var should be mutable. We just, instead of using the old variable, we use the new variable, right? Okay, let's say that scope is perform get scope, right? And then we don't execute, we say let var, let's see, new context var is generate name original non-context, and I say let var new context var to be equal to this expression over here, right? So the context var is the scope context var, right? So we basically are overriding the context var. We introduce a new field there, and then we have this in the new context variable, and then I also say that my current scope context variable is the new context variable after that. Okay, there we go. And then over here, so this is the beginning, this is the root scope. And this is my context variable of the root scope. So with global scope, prepend scope f. Tcap. Tcap with a raid. Hello, hello. Huge. Welcome, guys. You are coming from C++ into JavaScript. Do you guys like JavaScript? Look at this. I'm generating some JavaScript and it looks beautiful. We have like temporary variable number 28, temporary variable number 29, and number 30. And it prints hello world, imagine. Holy people live. Alright. How about OCaml? You guys like OCaml? I don't like it, but here we are. I'm fixing a bug. How's TCAP doing with the game? Are you working on your game? Release soon? Or not? All right, I'm making, and this over here is Kast. This over here is mini Kast, and this over here is Kast. So we have, like, we are working with like 4 languages at the same time currently. We have, I'm making my own programming language. It's written in OCaml, the bootstrap, and then I'm rewriting the language itself. So we have OCaml and Kast, and then while rewriting it in itself, I'm making a sub-language, which is a simple language, which we will use as an intermediate step, an intermediate compilation step, which is called minicast. And then currently the language is transpiled to JavaScript, so that's 4 languages, yes. And then Rust is not used here anymore, but it was written in Rust before. OCaml Rust JavaScript, the least based man ever. You don't like OCaml because of buggy LSP? Well, there's a lot of reasons to not like it. Maybe, I don't know. You think you will like it? You try, see for yourself. Maybe you will like it more. But I don't know. Imagining that you guys are C++ people. You like OCaml? I mean, yeah, LSP is buggy. The I don't know. Writing code is very difficult unless you write it in a very specific way. I find my like the language is highly recursive. Everything depends on itself. On like we have the compiler, which needs an interpreter, and like interpreter needs like compiler, and like all of the types are recursive because we have like values which can be types. Types can contain values inside of them, like, and those values can contain code, right? Like, so like everything is just a huge pile of spaghetti, kind of. And that is not very something that OCaml likes, right? So unless I make like the very standard compiler, which is having the complete stages of compilation very, very, very separate, then like having a huge recursive thing requires basically writing everything in a single file and like not using any. Like and if on top of that you want to have like, I don't know, a map from a value to something else, then like in order to create a map you need like a functor, and now you have like, and now you are in the recursive functor space in OCaml, and that's like just huge pain. What's an example of type that contains a value? It is I guess like the simplest example is the generic type, right? So like just the way the things work is when you have code like this, you know, you have a function like debug print, which is generic over t, and this has the x, which is of type t, right? So what is t in this case? Well, technically it's a type, but inside of the type we just have t. But what is t, right? This is a very specific value, which I call the blocked value, because it's blocked by the like, it's basically the value which we don't know the value of, so to speak, right? Which is basically the runtime value. Same when I'm compiling the code here and I say like just x itself, this is a runtime value, not a value that is known at compile time. But then when I actually like evaluate this generic, because generics are just functions technically, this gets the value of t being like some concrete type, and then we can replace this with something else, if you know what I mean. And like similar to that, this like for example you can have like an optional t. You can have an option t, right? And or I guess not option. Like you want something where the t specifically is a value, right? So how about a fixed sized array of size n, where n is an integer, right? So now this is not a type. This is a generic argument, which is actually a value. And so this is a type which contains the value inside, right? And I guess it, like, even if without the generics, it would contain the value technically, right? You dislike Rust a lot. It takes away all the fun, like buffer overflows and such, is directly threatening us security people. Please think of us and write in secure code. So that's a dependent type. Yes, exactly. We have basically we have a like for now I have the simple form of dependent types. Yes. So like technically you could like for like say over here like some operations too. I don't support all of the operations because like I guess I can see what we have there. Types. What do we have in blocked value? So blocked value is the thing which needs to be, which is basically a dependent on some runtime value, right? And right now it's just a binding to a variable or instantiation or a field reference or claiming reference, which is like kind of limited, but yeah. So instantiation means that like it means that when we do the types like this fixed size array, this is a known generic, right? But this could be an unknown generic, which is what you need to do to implement like more like basically higher kind types, right? So you have like M is a higher kind type, which is a generic which returns like a type, right? Which has the argument, which is, I guess in this case, n is an integer, right? So we can do these things too. So it's a HTT definition of type. Yeah, maybe, I don't know. HTT, you mean the homotopy type theory? I've only like read the basically and understood the like the type theory section in that, and once it went into like the actual homotopy, that's too much for me. I'm not that good at math. But yeah. So, and like all of this is driven by compile time evaluation, right? So like when I need to know what a type is just an expression which we evaluate, and it must evaluate to a type, and like all these kind of things. Well, there are like, I don't know if you're familiar with Zig. Zig does not have like dependent types, but it is kind of like similar, I guess. It's just not type checked basically until, I don't know. It's like something similar. Kind of. I don't know if there's like some theoretical background to the comp time like in Zig. Anyway. Yeah. So like this is the reason why we're making the minicast, so that I don't want the minicast to be a language with dependent types. We want something simple there so we can get started and like use that instead of compiling from this Kast with a bunch of features into JavaScript or whatever directly. We need the intermediate step, which is a simpler one for sure. Is there a notion of trait? We used so in Kast, traits are just types and trait implementations are just values, and they are going to be passed around as like, yeah. Well, I mean, if you are familiar with homotopy type theory, I guess, yeah, you would do the same, yeah. And they, but like, I want them to be passed around also implicitly, right? So similar to how Scala does it, I think is my current plan. But also, in addition, I think I'm not sure about Scala because I never used it, but I think it's always like passed at runtime. Sometimes for performance reasons, we still want this type, the trait value, to be like passed at compile time, basically, removing that as an explicit argument from the compiled function, which technically just means that I need to calculate it at compile time instead of calculating it at runtime. And runtime and compile time are already very intertwined, so it shouldn't be that difficult. But for now, I'm just doing everything at runtime. Well, I guess I can explicitly say something like evaluate this at compile time. Well, I mean, right now I don't pass them as arguments, actually. Right now I have the global map. My traits are not done fully yet. Basically, we have the runtime type information, and then I can look up the trait information in the global map, basically. You could use Kast for proofs. Yeah. I think we will get to that, but eventually. Yes, I want to try to go into the proof territory too, but I don't know how useful that is. I have never used a language that for writing proofs. Formally verified game engine, yeah. There is a lot of unfinished stuff though, right? I already can do a lot, but there is still a lot to do too, right? And I think I'm not working on basically the language anymore until I have the self-host ready. So I'm not going to have the type checking of context system or whatever. Or more dependent type or proof stuff. That's going to be long in the future, I feel like. All right, so here's the problem. We have the execute all is different. Wait, no. Not execute all is different. Hold on. What was I doing? And scope. This, where's this function being called? Here's the question. Right? So here we actually explicitly create the scopes, which is totally fine. Wait, hold on. I actually don't. Okay, hold on. I don't need this. No. I don't need this. I don't need to let var. I don't need to generate a new one here, right? Yeah, I don't. Because I always introduce the new variable anyway. This is going to be simpler. So I just say that context var is it's only new one for the root scope, and for all of the other scopes, it's just going to be equal to the parent scope, right? So this is going to be if root then the new one, and else it's going to be the the current scope context var. There you go. And then we'll just do that. But the thing is, I guess the implementation with global scope, because this is just prepend scope f, and this is not correct. Because prepend just does this. Maybe like, okay, it should be like, maybe it should be like scope. Maybe it should be like context var. So this will be like js var name option. Right, so it's going to be context var match context var with some var, and if it's none, then we actually get it from the parent. That's what I want, maybe. So we will have, okay, so with global scope, we prepend scope where context var is okay, global true. Fine, hold on. If it's global, then we do effect perform get context, not get scope. And the context is going to have like global context var, basically. Yeah. Otherwise, we get it from the parent scope. Which means that get context should have the global context var. Global context var generate name context. User code is impulse scope. Okay, I need to like make sure though that I actually pass this. I mean, I can make this an explicit argument instead, but I think it's fine. Right? I can just look at all of these. So with global scope, this is prepend. Yes, prepend early. This is going to be scope global true does match if then labeled block if and match loop unwindable this. And over here, this impulse scope is also going to be global is true, I guess. And yeah, and so like this context var, this is in the very beginning. This is going to be context, global context var. There you go. And I think this should work. All right, let's try. So we just do cast this. It didn't work. Wait, why did it not work though? Why did it not work? When I inject context, I say that in the current scope, I do this. Oh, wait, but I still need to do like the expression scope, I guess, right? So we don't actually need scope. So like I'm still doing it in the current scope. Yeah. So instead of saying actually need scope, we do something else. We say that we transpile this expression, but I am going to do that in a scope. Right? Scope will return the list of things. And all of these statements. How do I result is ref none. Result is some transpile expression. I guess I can do that. Now I can unwrap. Over here, result option unwrap. A little weird, but okay. And then I just need to inject these statements into the current scope. Right? How do I add in the expressions into the current scope? We just say execute all. There we go. Right, we just say execute all of this inner scope. Okay, now it's going to work, right? Look at this. Yeah, I fixed it. Okay, so and I don't like have the nestedness in the generated JavaScript either. So here's what we do, right? We have now context variable, which is like dependent on the scope. So, right, like over here, I'm overriding the scope, adding a new field. Yeah, so like this is like this, with context is being 1 to 3, because this value is 1 to 3, right? And this over here is the inner scope itself, and we don't actually have the JavaScript scope corresponding to it, because we don't need to. We just have the inner context there, which we stop using as soon as we exit the scope after that. Okay. Nice. Fix scope contexts in JavaScript. Let's also test though, just test using the advent of code that I didn't break anything. Time for an intermediate presentation, some optimization steps, and then generating JavaScript. Yeah, like, so I want this optimization to be done in the minicast, right? Basically, minicast is this intermediate presentation, which is going to be, I mean, I guess, easier to optimize before going into the JavaScript. So we can like produce cleaner JavaScript too. Maybe. Like we have a lot of like variables. So it seems like advent of code is all still working. So that's nice. Let's stop this. Update Kast. And whatever I was doing in the minicast, I think I didn't do so. Like I need to do the same with the scope. Like actually need scope. Actually, that's in the JavaScript, right? Yeah, we don't actually need scope. We don't do this. We actually do this. But we do this inside of the inner scope. Because scope is not just the block anymore. Scope also contains the context variable. But I don't like do the context here yet. Wait, actually, hold on. The minicast doesn't even have the context system. I think it will not have the context system actually, which means that I don't need to care about that. Right? So we just calculate the inner expression and that's it. Alright, we're trying to do the Fibonacci number. If it's going to work, I think that's good enough progress for today then. Kast mini. It is compiling. Let's cast color false mini test node. 89. I believe 89 is the correct Fibonacci number 10. Right? I believe it is correct. Alright. So we don't have like the number literals yet here. I don't know if I will need to add them. I can generate code like this. I mean, probably should. I'm pretty sure that we don't need to introduce the operators. It's whatever. That we need to have the functions, right? Yeah. Okay. Fibonacci working means in minicast means that I think I'm going to be done. Yes. I'm sorry, Pigorli, but the day can continue on another stream, I suppose. Which one? Rust game dev custom engine. And it's a card game, it seems. Is there audio? And they have like a cursor, which is blinking. Alright. Well, hopefully they talk. Oh wait, maybe they do. Maybe I just... don't hear anything because I was on the headphones. Anyway, thank you guys for watching. See you next time. Bye.